Uh, all right then, since it's already 6:08, we will start. And if other people are joining,
Okay,
I'll
ma'am.
let them in. Okay. So, welcome to yet another problem solving session for the course Geographic Information Systems. And the instructor is Professor A.K. Saraf from IIT Roorkee, and I'm the teaching assistant Anjana from IIT Kanpur. So, today we'll be discussing the week 7 topics, and which includes the database system and then regarding map projections. The DEM part I will cover in the next session because sir had just started that in the week 7 and then continued it in the week 8 part. So I've just sort of summarized whatever has been given rather than touching upon every topic as I've already told in the previous sessions. So yeah. So introduction to database. So before understanding what a database is or what database management system is, we need to have an idea on what is the difference between data and information. So what is basically data? Okay, so data is the raw facts that you get. Like it's just for instance, if you are talking about population data, then population data is basically it gives you the number of people in a particular area. So that number is the raw data that you're getting, and you have to make some meaning out of that. So data is basically raw facts. Okay. And when you organize these data into a computer or in a database and convert that data uh, facts into information. That is how you get an information. So the raw thing is the data, and the information is what you get out of it. It's like how you cook something. You have the raw material. Like for example, you're cooking some vegetable curry or something. So you have the vegetables, that is your raw data. When you cut it and then you compile it, you make some meaning out of it, that is your information. Okay, so that's just a analogy that I said. So in case of GIS, like we have data, uh, so we have data which when you process it, you get the information, right? So data, then you get information, and GIS takes it a step forward by converting this information into knowledge. So it's a little like data can give you information, but when GIS also comes into play, then you can get something even more valuable out of it. You'll get some knowledge. So GIS is capable of handling not only raw facts, that is basically data, it also allows us to convert that data into information and finally to knowledge. So like it, as sir said, like it talks about what is present, how it came there, and how it's going to transform after certain changes. So it's like, for example, what can I tell you? Like if you have a data regarding some earthquake events, okay, so you have an area and you have data on wherever the earthquakes occurred, its magnitude, the casualties that has happened, and the periodicity also sometimes you can determine. It's not that you can predict earthquakes, but then if you see that okay, in an area it's like in within this time span earthquakes are happening, so some kind of probable predictions sort of thing you can make. It's not an exact one. So anyway, so what I'm trying to say is data, it constitutes the building blocks of information. And what is written here? So information is produced by processing the data, and it actually gives meaning to that data. Okay, and timely relevant information is key to decision making, and good decision making is key to organizational survival. So it's like everything is connected. So as I was saying, like I got drifted away, but what I was trying to say with the example of earthquake is that, like for instance, you have all those information there, like the numbers, okay, like regarding the magnitude, the casualty, all those things, all that information is there. Now when you do some GIS analysis on it, then you get a picture of the how far a particular earthquake has affected an area, all those things. And then from that, sometimes you will be able to uh, not exactly predict, but you can make an assumption that how far its effect can be in the future, such things. Okay, so that's what I was trying to say. GIS always takes it a step forward by converting that information into knowledge. So the database management system, or the DBMS, that is available in all sort of GIS softwares like ArcGIS, QGIS. You have this database management system. So this basically manages the database structure, like what all data is there. It sort of organizes and keeps everything, and you can use it as per your requirement. It controls the access to data, and it contains the query language. So basically what we do in database management is that the data which is shared, integrated computer structure which houses the end user data and also a metadata. So metadata is basically the data the information about the data, what kind of information does that data contain, that is the metadata. So even in case of satellite images, generally when you download a free satellite image, you will have a file which is written as .met. Okay, like what all information is there regarding that particular satellite image, when it was acquired, what kind of satellite took that image, which kind of sensor is there. So that kind of information, not exactly what the image is, but rather the general information regarding the image that was taken. So the importance of database management system or DBMS is that it makes data management more efficient and effective. Also, query language allows quick answers to ad hoc queries. Like suddenly you are having a question, okay, you just raise that question through and you get the answer from the database. If it is having that information, obviously you will get that data, and it provides the better access to more and allows you to better manage the data. It promotes an integrated view of the organization's operations and reduces the probability of inconsistent data. So this is why you need a database management system, and this database management system, it gets updated, and more information gets organized and put into the database management system, because we have a lot of technology and facilities available right now. So unlike how it was in the beginning, it contains even more information at present. So in case of database, a good design is the key. Like starting point has to be very good. If poorly designed database is what you have, then you will have a lot of data repetition, like redundancy. Okay, so that kind of proper management of the database design is very much necessary, because data redundancy, that is basically data is lying in the database, but it is not accessible to anyone, and data is just occupying your storage space. So you only have to keep that data which is needed by you, and not some additional data which is basically not useful or hidden. So that is a very bad example. Example of having a poor database design. Poor design, it also generates errors, sometimes leading to very bad decisions also. So you have to, the best database design can give you the best output in a GIS analysis. So sir had given you an example, if you remember, regarding the IRCTC portal. So he had said that, like, if you have the IRCTC portal or the software design database, which if suppose that was poorly designed or having some errors, then it can create complete havoc in the railway system. Because as you know, in India, the railways is one of the most used mode of transportation by the people. So if that IRCTC portal or its software database is very poorly designed, then that is significantly going to affect the proper functioning of the railway system. So immediate correction, like if you find some problem in that, then immediate correction is required. Otherwise, because as you know, like the seating chart and everything that is prepared based on the data that is available. So if that data redundancy is there, or if the design is very poor, then sometimes what happens is that wrong seat in a wrong train, or on a wrong date, all kind of havoc can be created. So good designs are very much important. And now regarding this practical approach, focus is on the principles and concepts of database design and the importance of logical design. Now, this is regarding the file terminology that is associated with the file system. So we have data, which actually refers to the raw facts. Then we have the field, which is like basically a group of characters with specific meaning. So it's like I think I have an example also, so that I can show you. Then we have this record, which is logically connected fields that describe a person, place, or thing, and file is the collection of all related records. You have to remember that these terms are still being used through the GIS file system system, but not in mostly in database. I don't think it's used. So when we go for this database management system, it consists of logically related data stored in a single repository, in a single place. Repository means a storage unit or something like that. So in that single place, you have logically related data that is stored there. So all kind of information you can get from there. And that is the advantage. It's not in different files. So in file systems, you have to keep like you may have the information, but it is kept in different files. But in case of database system, they are all that logically related data, it is stored in a single place. And all these are related with logic and organized in a fashion which that our access to the data or retrieval of information becomes much easier. So if you remember in the definition of GIS, this data is coming from variety of sources and it allows the easy retrieval of the data. So if it is organized in a proper database or well-designed database management system, then only efficient storage and retrieval is possible. Otherwise, it's not. So it's like you're not going to one minute, my So the advantages of database system over file system management approach is that it eliminates inconsistency, it eliminates the data anomalies, data dependency, and structural dependency problems. It stores data structures, relationships, and access paths. The basic idea is that unlike the file system, the database system, like both database and file systems contain data, right? But then in case of database systems, that data is logically stored and in a single place. But in case of file system, you have a lot of information available, but then that is not, that is in different places. So you have to go find it and then figure it out based on your requirement. But in case of database system, if you can just type in like I need this kind of data, and if it is available and if it is properly stored there, it's just a matter of a click away. So in summary, we can say that if in a database system, we are having a centralized database management system, as you can see here. So as you can see here, this is the DBMS. So it has a centralized database management system, and different departments may work independently. Like you have the personnel department here, sales department here, accounting department here, all of them doing their individual jobs, but then they are all connected with one database management system. So whatever information that they are generating, that is stored in this database management system. Okay. Whereas in case of file system, if you take a look at this, all people are working for the same organization, but their information are independent to each other and every information is lying in isolation. So personnel department is related to the employees, sales department to customer sales and inventory, accounting department to the accounts. That is all. But if you have a database system, all of them are interlinked and interconnected. So that is more convenient because they can, work in unison rather than working separately. So, and yeah, of course, as I said before, the database system, the data is logically connected or related. One minute. Okay. So, yeah, as I was saying, so in case of database system, like these terms, it's better that you keep in mind. That's why I'm saying it again and again. So, in case of database system, you have this data which is either logically related or connected. And therefore, getting information from one department to another is easy, but in file system, it is going to be difficult. Excuse me. Okay. Oh, I'm taking the class of week seven discussion because that's the one like I was supposed to take on Tuesday, but I couldn't. So I'm taking that. Like this should be, I think, the last part of week six. But since in week seven also, sir had continued with the database part. That's why I took one lecture from week six and then the rest from week seven. Okay. So if you take a look at this is the database system environment. Okay. So it has some procedures and standards. So nowadays, like it's very important to talk about standards and also regarding the database management system because somebody can change to some other DBMS and allow the access to your data. Like nowadays, data is a big deal, right? Because we say that you know we although we put all these protective things on our phone or on the internet, but basically a lot of data is being collected based on the our activity on the internet or like whatever it is. So data has become really important in the present time, in this digital time. So it is necessary that the database system follows some standards and all these parts will be very easy to gain access to.
One thing in the picture is feedback is missing. Feedback from the user.
Which one?
Feedback. Feedback from
Oh,
the user.
feedback. Oh, okay, okay. I had taken the image that sir had given exactly like that. I think that's why I missed it out. You're saying this image, right?
Yes, ma'am.
Oh, okay, okay, okay. I had directly taken the image that sir had given. That's why it's missing. So as I was saying, so the standards like procedures and standards is important because sometimes what happens is like one person like one organization stores data in one format, the other organization stores it and in another format. So that kind of difficulty comes, right? Like two different formats, it's not easy to handle. So accessing that database might get difficult. So if certain standards are followed, then these problems will not come. And then there is an application program which allows the end users to access the data. So this, as I said, we have the procedures and standards which is necessary, and then we have the application programs. Okay. So in case of this, it allows the end users, like whoever, all these analysis, whatever it is there, and finally to whom it reaches, it allows those end users to access the data. Programmers, they basically write the programs so that we get access to those information. The end users through application programs can access the data. This is the DBMS basically. Okay. So you have a system administrator, you have a hardware, you have the database management system. So ultimately it is going to benefit the end users. So as again sir had given you the example of IRCTC or a railway, we, the people who are booking the tickets, we are the end users. So we are using through like booking that through the network, internet interface program on the net. We log in, we get into a program which is the IRCTC portal, right? And then what happens? We start accessing the database management, which is very updated almost like every second. What is the database? Like on which day you're going to travel, how many tickets are available, that too, like in sleeper, how many are available in second AC or third AC or first AC, whatever it is. So that is like being continuously updated also. It's not like now you do it and then they update it later, and then that's going to give misinformation. So it needs to be properly updated almost like every second. This is of course we have the system administrator who controls everything. There will be a database administrator. So we have a system administrator who is controlling all these things. Then we have a database administrator, which will focus mainly on managing the database. And then you have a database designer who like very frequently they have to change the design like according to the user output, like as you said, the feedback and stuff like that. So they have to frequently change it, like at times for ease of access of that portal, or at times especially if the example of IRCTC, like if they have to add a new train or a new class or new route, all those things are taken care of by the database designer. Then you have the uh, these procedures and standards that we said, they are connected with the rights, and standards are enforced through data administrator. So likewise, we are there as the end users. And one important thing is the data is there, but important point about the backup, because such important system has to have a very good backup in their system. Like, all that information needs to be backed up. Like how, if all of us are using smartphones, right? And we have a lot of photographs on our phone, and at times anything can happen to our phone, or sometimes what happens is like our phone storage can get filled up. So what do? We pack it up in a Gmail account or something like that. So similarly, a backup, proper backup is required for all these data set. Then we have different database system types. So whenever you design a database, it's either going to be used by a single user, that is like one user at a time, or multiple user, like as the example of IRCTC. So like I'm using from here, you might be booking from your home. So that is like multi-user database. Single user is like one person is using at a time. Okay. So this can be like people using the desktop, work group, or even in enterprises. Like right now, earlier it was completely like done on computers like desktop computers or even your laptop. But now such things, almost everything that you do on these systems, you can do it on your smartphone. So that is a good ease of use and access for the user. So that way, the database designers should think in the beginning nowadays, because that is the most, like, phones are the most common devices that is being used. And again, they have to decide about the centralized or distributed systems. People talk about cloud or other systems, which is like great, and it can. So, can we have a centralized system or should we go for a distributed system? That kind of thought process also needs to work. Then regarding who is going to use it, and like for what reason are they going to use it, so such things that is taken into consideration when the database system is generated or made or modified or updated, because the database system will depend on all these parameters. And of course, production or transactions, like in banking, like ICICI Bank or like State Bank or whatever it is, they have a database that's known as transactional. Or if it's like in case of some factory, like, what do you say, some cloth factory or something like that, then it is like product related. It's not transactional, right? Now, whether my data is related or database management system is being designed for making good, timely decision, or like, that is all the things that you have to keep in mind when you design the database system types. Now we,
Ma'am, weather related database
huh?
comes under weather related weather related database comes under which?
That will be, I think, centralized. Like, you're asking single user, or like what kind are you asking me?
It is weather.
No, no, I understood whether. So you are asking
Yes.
me regarding the user type or the centralized or
User
distributed?
distributed, multi-user. All everybody know what is the weather condition of the
Yeah,
location.
exactly. Huh. And that also, like, whether I have to check it actually, because see, like in our country also, like we have this general weather information also is there all over the country, and then we have this local weather system also, right? So that I'm a bit doubtful now, because you asked, I was thinking about it. But yeah, otherwise it's like a multi-user database, and then probably centralized also. I can check it once, just a minute, so that there is no misinformation. Okay, so I was just going through a material. So in that, they're saying that this weather data management, it can be both centralized as well as distributed. So, like in centralized DBMS, we have all the weather data that is stored in a single location, which is like a central server or a data center. So, you have this national meteor. That's what I was saying. Like, we have this national meteorological department which colors all weather data in one mainframe. Like even the historical data will be there, for 100 years before, such things. The benefit of this is that it is easier to maintain, and it has consistency and security. But the problem is that it's not that accessible for remote users, and if you have to look for a specific thing, then it can fail. Like for a broader purpose it is useful, but if you go and try to locate a single point, it can at times fail. But the distributed DBMS for weather data, It stores data across multiple servers, often in different locations. So this is common in real-time weather monitoring, where data from satellites, weather stations, all this is processed and stored in multiple locations. Like you have this NOAA. I don't remember the exact full form, Antarctic something. Then we have the NASA, and then we have the IMD. So they use distributed database for real-time weather data. So the benefit of this is that we have a faster access, and the problem is that it's a little complex to manage. Data consistency can be questioned. Like we don't have to go into that detail. Just as conclusion, you have to understand that for large scale real time weather forecasting and analysis, we use the distributed DBMS. But for historical weather records or like small scale applications, the centralized DBMS is more than enough. Okay, so now we will go to the different database models that were discussed. So just a minute. So yeah, the first one. So you have to remember that this database models, it's basically a collection of logical constructs which is used to represent data structure and relationship within the database. Now these conceptual models in which logical nature of data is represented and the implementation model are the ones which emphasize on how the data are represented in the database. So basically what I'm trying to say is we have this database model, right? So that can be conceptual or it can also be implementation. Models, okay? So the conceptual models are those in which the logical nature of data is represented, and in case of implementation model, it actually emphasizes on how the data are represented. So the first one that we are going to discuss here is the hierarchical database model. So it's logically represented by an upside down tree. So the logic is that each parent can have many children, but each child has only one parent. That is the logic that has been used. So if you take this example that sir had also given, like from IIT Roorkee setup. So this is represented here like we are having the main parent, which is the institute. So the institute name, this is the field name. Okay, and then this is the data record, like field name is institute name, that which is IIT Roorkee. Okay, and in this institute it has several departments. So department name, now since we are mostly talking about the GIS, so we are talking about the earth science department. So let's say the department name is earth sciences, number of professors, number of staff, number of students, that record is given here. That is like basically each department will have students, faculty, professors, courses, so all those things. Okay, so if you want to store all that data in our database management system, we prefer this hierarchical model. Then like for instance, like IIT Roorkee department, then within this department, the student ID, like one student record is taken, employee ID, then course ID, like which course, so such information, all those information you can take. So here the parent is the IIT Roorkee, that is the institute is the parent. Then it has several, like let's say department is the child, Within department has other children, then those children have their children, like that kind of thing. Okay, so each parent can have many children, but each child has only one parent. That is the logic for the hierarchical database model. So this is like how when we study also sometimes we use this, right? For better understanding, when you map whatever you studied. So then you kind of do this hierarchy thing for better remembering whatever you've studied. So that kind of logic is being used here also. Now this hierarchical database model, like we have different database model, right? So each database model has its own advantages and its own disadvantages. So the advantages is that conceptual simplicity, like it's more easier to grasp what is going on. Like here it's easier, like just by looking at this diagram you are able to understand that okay, this is giving you an information from the institute IIT Roorkee, from the earth science department regarding the students, the employees, or the courses that is involved. Okay, so such information is that, like, it's very that simplicity is there in this one. So that's what we say, conceptual simplicity. Then the database security and integrity is good. The data independence is there, and efficiency is also there. So the data independence, what they're saying is that data is lying in different locations and can be modified by the individuals. Like for instance, um, the department, like there might be several departments, right? So for instance, the department of earth sciences, that information will be handled by the members of that, their office members or something like that. Similarly, if some other department is there, then their thing, like details will be handled by their office people. So that's what I'm saying, that data independence is there. So what are the disadvantages? The implementation. So when we try to implement, like if a student would like to take an elective course or some like other department course or something like that, he cannot do it in this database system, and it's difficult to manage. There will be a lack of standards because simple things are being kept in separate files or folders, and no standards are basically followed. This is like a very simple basic representation, that is the hierarchical database model. And it lacks structural independence, and the applications programming and it's use complexity, and there is implementation limitations. Like this is a very basic thing, like this gives you a basic idea. That's it, nothing much is involved, or that not that much complexity is involved in this hierarchical database model. Only thing you have to remember is that it is represented by an upside down tree, and the logic used here is that which is written here. Each parent can have many children, but each child has only one parent.
Control. Okay.
Yeah. Then we have the network database model. So here, each record can have multiple parents. So this is how it is different from the previous one. There, a single parent was there. Here, they have multiple parents. And it is basically the what we call as the network database model. So when we have been discussing in the network analysis, in the analysis part of GIS, uh, those sort of things, like I think, yeah. So it's better to mm, give explain with this example. I think that would be better. So as I was saying, unlike the previous one, the hierarchical model, this is a little complex. Not as complex, but then this is a little complex. So here we take the same example, but we see it represented in a network data model. Okay. So it's almost same example is there, but then we are looking at the network data model. So in the same way, we have the institute, then we have the department details here, then we have the students, then we have the professor record, right? Now, even the course information is also there. So this was all available in our hierarchical model, right? Till this, it was there. Okay. Now, through registration of the students or their enrollment number, the courses are now directly connected. And the courses are connected with the professors, and the courses are also connected with the department. So the student of other department would like to take courses. If a database has been managed like this, then there should not be any problem. So this is like earlier figure. If you take a look at that, so here we had the institute, we had the department, students, professors, courses. But because there was a lack of connectivity between these courses and students, that kind of thing, it was difficult for instance, if a student from another department had to come and take a course, it's not very useful. But in this case, because this registration process is there, so the students can easily register for the courses. This is all common as compared to the hierarchical data model, but what are the additional things is the registration record which is being kept here about each course, and students data is also linked to that. So that this particular linkage that you see here will provide some additional information and additional access. So here the department is directly linked with the courses. Department is also directly linked with the students, and department is also linked with the faculty. Unlike the previous one, where the department was only linked to the uh, student record and the professor record, but department was not related to the course record. But here, if you see, you can see that the department is also related to the course record. So they have a kind of a centralized thing, like it's all connected, right? So again, in like hierarchical database model, the network database model also has its own advantages and disadvantages. So because here, if you take a look at this, the advantages, again, you have this conceptual simplicity, but if you remember, like in the hierarchical model, uh, unlike the hierarchical model, here the relationships between courses, teachers, faculty, so on and so forth, all that can be handled. So it handles more relationship types. Okay, but if you take a look at this, it doesn't. Basically, it's very simple kind of model. So that kind of relationships are not taken into account. Here, data access flexibility is there, promotes database integrity, data independence. Like it's more or less similar to hierarchical, but here this is the point that you have to keep in mind. It handles more relationship types, but hierarchical model does not have that kind of networking or connectivity. The disadvantage is that system complexity is there, and lack of structural independence. Because system complexity is that you have to maintain the data, like you have to uh, make sure that it is updated and everything. If that is not maintained, then all these will going to drain. And then connectivity, would like who would have access to what, that kind of thing should be there. Lack of structure independence is same disadvantage as in case of the hierarchical model. Then we have the relational database model. So this is a third type of model which is commonly used in GIS, and useful also compared to the other two that we have discussed so far. Okay, so this is basically perceived by users as a collection of tables for data storage. You know that for each layer you are having a table, like you remember the attribute table that we have for each layer that you work with on the GIS software. So we have this attribute table. So if you're having point data, you are having the attribute table. If you are having polyline data, also you have this table, and even polygon data also you have a attribute table. The information is stored as relational database, but in the form of tables, uh, at least on the display side. So tables, as you know, they have a these rows like this, and then it also has columns like this, right? And so you, like for example, this is the map that you have. Then you give the map ID. So you have 11, 12, 13, 14. So those information is here. Then for each of that ID, you have information regarding the area, perimeter, and I'm not sure what the stand number is, but yeah, that is also given here for each of that. And in case of attribute table 2, that's kind of like a sub table kind of thing. So for each of the uh, oh, okay, okay, no, no, I'm sorry. Like it's not sub, it's a continuation of this, I think. J 127, 128, 129. Then what all dominant species are present, and then the age. I, I'm sorry, I don't exactly remember what was discussed in the attribute table 2. Let me just check.
From J1 to 127 information, I think.
Yeah, okay, okay, yeah. Now I understood. Okay, so the thing is, what we were trying to do here is we are trying to link these two tables. Okay, that's what I was trying to find where the connection is. So here we took the link between 14 that is on the map. We found it on attribute table 1. Then in this table J127 we found its connection in attribute table 2. We got this. So it's like we are connecting it. That's what it was found. I'm sorry, I was just trying to uh, think in the hierarchical thing. So that's not how we are finding the relation here. So here what they have discussed is that like in these two tables, we have a common field which should be common in both databases or both the tables. Now, if that common field is there, then it will also have common characteristics. So basically, you have to find out the common entities that are present. Like for instance, sir, I think that was the example that sir had mentioned. Like we have the soil sample data and the sample area which is given here. So you also have a land use map. Okay, like so soil data is also there. You have a land use land cover map. Now we have to relate this soil data with the land use map, which means both these tables should have a common field which should have common characteristics. So that is how it is being connected. Now, if I can relate these two tables very easily if some common field can be identified. So here, the common field was J127 like you said. So that J127 can be found in attribute table 2. So just like in the other cases, here also the attribute like the relational database model has its own uh, advantages and disadvantages. So the advantage is that again structural independence is there, improved conceptual simplicity, like it's more or less the same thing comes under the advantages, like slightly some variation might be there. Okay, so easier database design, implementation, management, and use, ad hoc query capability with SQL, uh, then the powerful database management system. The disadvantage is that substantial hardware and system software is required, it, that requirement is there. Design is poor and implementation is made easy. It may promote islands of information problems. So islands of information problem is that different databases may have the same information or same field, that is like not one common field but many common field. That's going to make it a little difficult. And one database has been updated, others may, if that is not updated, then we cannot relate the two tables. So that's going to be creating a lot of complications, because we are trying to connect the tables, and if one is not updated, then that connection cannot be established, and you'll just be having a lot of information at your hand, which is not like you're not able to connect anything. Then we have the entity relationship database model. Just a minute. So here it complements the relational data model concepts. It is represented in entity relationship diagram, which is given here. We will discuss that. And it is based on entities, attributes, and relationships. So like here, we are having a painter that is given as 1. And this is the painting, but no, like painter is here, painting is here, and they have a relationship with the paints. Okay, so this kind of entity relationship model uh, will allow us to complement or the things which are not possible in relational database model might be possible in this entity relationship. So only thing is that painter is there, painting is there, like that painting may not be of this painter, but the that's, I think that is what they're trying to convey, but the common entity between the painter and the painting is the paint that is being used. So what are the advantages of this? It has exceptional conceptual simplicity, just like in case of relational database. Visual representation is possible, obviously. Then effective communication tool, that is like it is easy to communicate, easy to explain to the people how things have been organized. It's more visual. So whenever we see an image, that stays in our mind better than what is written, right? So it's more visual. That's why we say visual representation is good, and thereby effective communication also takes place. Then it can be integrated because it is complemented, not competing with the relational database model. So it's like you can sort of connect it with the RDBMS and then work with it, so it gets more refined. Now, the disadvantage is that it has limited constrained representation, limited relationship representation. Like constrained representation is there. There might be, that might be there in some cases. Then there is a relationship limited representation. Like it will not be possible to link or create something like that of network kind of database. Like that relationship thing is only related to the network database, but not in this case. So simple relationships can be represented, but as you go a little more ahead, it gets complicated. Also, for that, the network model is much better. So no data
Madam,
manipulation.
ma'am, IRTC is come under network or which?
Which one?
IRTC, railway.
Oh, IRCTC. I think that will come under network model mainly, but it's a
Yes, ma'am.
little more complicated. Uh, 1 second. I'll just check it so that I don't give you any wrong information. It comes under relational databases. Like I was just going through it, so they are saying that IRCTC uses the relational databases because uh, that's possible also, because it has a lot of information that it has to handle, right? Because we have multiple trains that are present, then multiple, like in one train itself you have different compartments, so allocating each of the seats, so it will come under relational database model. So yeah. Then we have the object oriented database model. Okay, like this people also call it as the OODS, basically as the name suggests, object oriented database. So it is the same concept that objects are abstraction of real world entities. Like objects or abstractions of real world entities are stored. The attributes, they describe the properties. Collection of similar object is a class. In the previous classes or like previous sessions also we had discussed, right? So a lot of similar things, like for instance, if you have a digital elevation model or something like that, so we have class 1, class 2, class 3, which might be representing the different relief range that you are taking into consideration. So collection of similar objects is a class. Methods represent real world actions of classes. Classes are organized in a class hierarchy. Inheritance is the ability of object to inherit attributes and methods of classes above it. So what you have to understand is that uh, we are representing the real world in an abstract form. So that is what is being done in this object oriented database model. Okay. So the attributes that you find, they describe the properties. So where even if it is raster or vector, whatever the attributes they are describing, uh, what phenomena, what information is there. You're asking like from which week class I'm taking? Uh, I'm assuming that you're asking me that. So this is from the week 7. Week 7, first lecture, I think. Yeah. Like because sir had been discussing this, like he started that discussion in the end of week 6. Then he took one lecture on, first lecture was I think on week 7. Then after that, sir took it to map projections. So this is like mainly we are focusing on week 7, but I have taken a little bit from week 6 also. It is there in those PPT, like if you take a look at that. So this inheritance ability of objects to inherit attributes and methods of classes above it. ODM is there in one PPT. I'll have it's there. It was given after the entity relationship database model. I think it is there. I got it from that PPT only. What like whatever information I've given here. Um, but if it's not there, you can take it from this PPT. Like I'll be uploading this, so you can just have a look at it. Okay, so the advantages of this OO data model is that it adds semantic content and visual representation, includes the semantic content. Okay. So, 1 minute. My pen is a bit stuck. 1 second. Okay. Now I think it's working. Yeah. So, yeah. Uh, what is this link that you have shared right now? I didn't understand. Uh, did you share the link for the PPT or something else? Okay. Huh. Yeah, you can share the right link. I can check it once if that PPT and the one that I have is different or not. Yeah, you can share the link in the chat. Or maybe I can cross verify like if the PPT I have and the one that you have is same or not. This is the week 8 one, right? Which you have shared. The DEM thing. I'm discussing the week 7 part. I have not opened it on my computer. Otherwise, I could have shared it right now. You can check it and share it with me, or it's okay. Like, anyway, I have given it here. So, if you want this notes, it will be definitely be shared in the link that is provided in the, I think, the NPTEL page. So, you can gain access to this. Okay. So, yeah, we were discussing the advantages and disadvantages. So, yeah, advantages, it adds semantic content. And the database integrity is quite high in case of this object oriented database model. Both structural and database independence is also there, which is not common in previously discussed database models. Okay, thank you. Now the disadvantages is the lack of ODM. Like the database management is not that good in case of this database model. It has complex
Madam, madam, sorry, what
uh,
is semantic content?
what? 1 second, my speaker has some problem. Let me just increase the volume.
Yeah, add semantic content. The first one, advantage.
Okay, just a minute. Semantic content, I like it is like symbols like words, graphs, and other representation that is used to represent the real world thing, a more graphical representation kind of thing. So, this object oriented database model has such uh, information available.
Okay.
I think semantic models are also there in GIS. So, if I can show you some example or something, then you might understand. Yeah, there is this definition. I was just searching it. So there is this definition on the internet, which is they're actually explaining the geospatial semantics. So is that true? Like geospatial semantic integration provides a global view. Like for okay, a geospatial object is described as a river. Like they're giving an example in one data source and a water body in another source. The geospatial semantic integration reveals that the two terms. Just a minute, let me just go through it. Hmm. What I am understanding is that, for example, you have a geospatial object, okay? So that is, they have given the example as river. Now, this river, uh, like that geospatial object, it is denoted as a river in one data source and as a water body in another source. But essentially, both this name, like that river as well as water body, both are same only. Like they both are referring to one particular object, geospatial object. So what this semantics does is that it will integrate, it'll let us know that in the real world this is just one thing and it's not two different things. So I think it gives you a more in terms of symbols, it gives more idea regarding the symbols
Ma'am,
that is being used.
ma'am, legend, which legend will give that river or water?
Hmm? No, no, what I'm saying
Legend.
is, like, for
Yes.
example, in the map you are having like this. So you have this, something like this, okay? You're not naming it right now, but let's say in one of the, attribute table, this is described as a river, and in another attribute table, this is described as a water body. Okay, like they are not specifying that it is a river or something. So in two different tables, the same object is getting two different names. Like one place they are saying it is a river, in another place they are saying it is water body, but both the names are referring to this object, right? So we are basically integrating and saying that, okay, these, although it is referred to by two different names, it is actually referring to this one single object. Like basically the two terms mean the same thing in the real world.
Okay, ma'am.
Maybe like now I just checked it and I'm giving the example. Maybe in the next, I'll just note it down so that I can tell you more if possible in the next class. Okay. Then it has, okay, so we were discussing the disadvantages, right? So the database management is not so good in case of object oriented database model. And then it has complex navigational data access. So like for instance, if you want to develop some kind of query language or something like that, because of this problem, this navigational data access problem, it might not be possible. Then it has a steep learning curve. Like it's not very easy to learn this object oriented database model, and high system overhead will slow the transactions because you require a much more efficient computer, and therefore that might add extra cost. Or like if systems uh, like has high speed, then they may slow down the transaction or processing. So it's basically like it costs, it costs more, uh, this object oriented database model. Okay, then that brings us to the next topic, which is map. Oh, before that, I think I. No, okay. I didn't miss anything. Okay, so what are maps? Like we have seen this atlas at our home, right? In books format, we have seen maps. In digital format, we have seen it in as Google Maps, or even in Google Earth, we have the 3D maps. So, what are maps? Maps are models of reality, like what we see on Earth that is represented in a paper or on the computer in the form of maps. It attempts to represent the two-dimensional curved surface of the Earth as a flat surface. So, as we know, Earth has a curved surface, right? And it's not exactly a sphere, it's more of a oblate spheroid kind of thing. So whatever it is, we have a curved surface. Like we, for us, the place that you are sitting or standing, whatever it is, it appears flat, but it is part of the Earth's curved surface. So that two-dimensional curved surface of Earth is represented on a flat surface, and we call them as maps. And maps are the main data source for a GIS analysis. So how is a map constructed? So any map, you construct it, like each country will have its own, right? India map is there, then we have some other country, like maybe let's say uh, France, they have a map of their own. So different countries have different maps, right? So in first thing that you have to do is select the map projection. Okay. Like for example, in case of the India topo sheets, like we have these topo sheets that are available. Different, like I think when we discuss map projection, you will understand that better. Like you have to understand there are different map projections that are available. And what does map projection mean? Like we have this Earth's, like Earth can be a sphere or ellipsoid, right? Whatever it is. So it has a curved surface. So we have to represent this three-dimensional thing on a flat paper or a flat surface. So for that, you need to do map projection, which we will discuss in detail. So selection of a model for the shape of the Earth. It can be sphere or it can be ellipsoid. All these are basically dependent on what kind of map you need and what kind of information you are expecting from the map. Based on that, you will choose what kind of projection you have to do and what kind of model that you need to choose. Then what will you do? You will transform the geographic coordinates, which is the longitude and latitude, to plane coordinates. Plane coordinates means eastings and northings, or like x, y. Okay. So I think you are familiar with the longitude and latitude. So like on Earth, we sort of divide it into longitude, which is this elongated one, like the vertical lines, and then we have the latitudes. So each of it will have, each point will have a lat long value, and what we do is we transform this geographic coordinates, longitude, latitude, to plane coordinates, that is xy. Then if required, we will reduce the scale also. Like we don't, if we don't require a large scale map, like which gives you a lot of information, we can actually reduce it into a small scale map. So as I was saying, there are different kind of map projections. We have the conic projection, we have the cylindrical projection, we have the plane projection, then we have the interrupted projection. So this is just a image representation, but I think we will understand it better when we discuss it in detail. So map projections, um, they are used to display, as I was saying, the locations on the curved surface of the Earth on a flat sheet according to some set of rules. Okay, so like for each projection, we assign certain rules. So according to your need only, you will choose like which projection you require. So what happens is that when you do this projection by setting these rules, effectively what will happen is there will be distortions. Distortions means some kind of changes will be there. Yeah, on what? On the shape of a region, the distance between 2 points, the direction from one point to another, or the area. Okay, so all these things or some of these things will definitely change depending on the rules that you set. So map projections are used to transfer or project geographical coordinates onto a flat surface. So the easiest way to try to transfer the information onto a flat surface is to convert that geographical coordinates into XY coordinated system, where we will represent the X as the longitude, like the longitude will be represented by X and the latitude will be represented by Y. So this is an example of projecting onto a plane. So you can see this curved surface has been represented in this manner. So this particular part, this slice has been represented here. So each projection will take into consideration a different thing. So that we will take a look at each of that. So the first one is the cylindrical projection. Okay. So a cylindrical projection usually places the earth inside a cylinder with the equator tangent to the inside of the cylinder. So if we take a look at the earth, we are considering here a spherical uh, model. Okay, so we have the equator at the center where you have the latitude value of 0 degree. Okay, so what we are doing is we consider the earth to be kept inside a cylinder. Okay, that is the name, as the name suggests, cylindrical projection, right? So we have a cylinder, we keep the earth inside that. Okay, how are we keeping it? Such that the equator is tangent to the inside of the cylinder. What does tangent mean? Like a single point of contact, right? So if you keep the cylinder, this a single point of contact is there on at the equator, only at the equator. So accordingly, we are placing the earth. Okay. So it preserves the right angles between the lines of latitude and longitude and are primarily used because they preserve the direction. So this is why I was saying, like, each projection has its own purpose. So the purpose of cylindrical projection is what? It will preserve the right angles which is present between the lines of latitude and longitude. Okay, like at this point, whatever right angle is present, that is preserved by the cylindrical projection, and also it preserves the direction. This is important. Whenever your purpose is to understand the direction better, we will use the cylindrical projection. Area is always distorted on the cylindrical projection. So if you look at a map which has been using the cylindrical map projection, then you cannot calculate the area accurately in such maps. Why? Because they get always distorted in the cylindrical projection. So this cylindrical projection, it is also called as conformal projection. That is another name. And why it is called as conformal projection? Because it preserves the right angles between lines of latitude and longitude. So this thing you have to keep in mind. This is why we use the cylindrical projection. So why is that the area is going to be distorted? Because here on the globe, like if you take a look at this, we see that all these lines are actually curved, right? But when you make like bring it onto a flat paper, they are becoming straight. That is why we have a distortion with the area. So a good example is the Mercator projection, that is conformal. So this is how the globe is going to be, or the boundary of countries would be represented. But the big problem that you're going to see here is over Antarctica, over here at the bottom. or the northern pole countries, but the areas in the mid latitudes around the equator would be well represented. Because as much as you go closer to the poles, okay, so here you have these lines. So as much as you go closer to the poles, it's a bit difficult. But then if you take a look at the center portion, that distortions are a little less. So for the same area of earth, we are having several squares. In the near equator, we are having rectangles like this. So at some places we have square, some places we have rectangle, so it's not very uniformly represented. So in case of India, since India is like more or less near the equator, like the region near the equator, that distortion is a little less. It increases away from the central meridian. So what happens is, like for the Indian map or something you're dealing with, this Mercator projection can be used because that much of distortion is not present near the equatorial region. And since it preserves the direction, it is more like such maps are mostly used in case of sailing, like somebody who is going on a ship or a boat, they would prefer a map with the Mercator projection. Then we have the conical projection. So in conical projection or equal area projections, like how we named the cylindrical projection or conformal projection, so conical projection, it's also known as equal area projection. So as the name suggests, it preserves the property of area, unlike the cylindrical projection. Okay. On an equivalent projection, all parts of the Earth's surface are shown with the correct area. Latitudinal distance are never accurate. So in a conic projection, a cone is placed over the Earth. So just like how we had a cylinder there, here we are using a cone. It is normally tangent to one or more lines of latitude. So in the previous case, you had the Earth kept inside a cylinder and it was tangent only at the equator, right? But here it will be tangent to one or more lines of latitude. Like we have several lines, 20, 30, 40, 50, 60, like that. So it can be one line or it can be more than one line because it's in the shape of a cone. Only thing you have to keep in mind is the cylindrical projection area is distorted, but here that property of area is preserved. So this preserves the property of area. So a good example of that is Albers equal area conical projection. So here, because when we go for that's okay. So this here it distorts the scale and distance except along standard or parallels. Then we have the azimuthal projection. So azimuthal projection, or I think it's also known as planar projection as it is given here. Okay, so here it only preserves the correct distance relationships along a few lines on the map. An azimuthal or planar projection is usually tangent to a specific point on Earth's surface but may also be secant. Secant is like it's cutting along a particular latitude kind of thing. This red area you see, so that plane is cutting along that, or it can be just tangent to a particular point also. So this point or focus may be a pole, the equator, or some other oblique point. That is how azimuthal projection is done. And an example of that is Lambert's azimuthal equal area projection. So here the area is preserved. but it distorts the shape and distances. So what you see in Google Earth, this projection is used like azimuthal projection, but when you zoom into it, uh, then these distortions are coming because of the curvature of the Earth. Like that will not be accounted for when you do the distance measurements. So in all these cases, the scale is important actually. Like large scale, small scale, like how much you're zooming in, how much you're zooming out. Depending on that, the information can vary. Like at some particular scale, the distance information might be right, but probably when you zoom in, uh, because that curvature of the Earth is not that well accounted for, that distance information can be wrong also. Okay, so we will go to the problems for week 7 because I think I'm not sure if it has already been displayed on your NPTEL portal, but since week 7 solutions were already shown there and your submission date is passed, so I'm discussing those here. So, which database model is logically represented by an upside down tree? You can give me the answer in the chat box also if it's convenient for you. We had discussed different database model, right? So which is represented by an upside down tree? Yes, the answer is hierarchical. In which database model tables are related by sharing common entity characteristic? This also we have discussed. Something which is related. Yes, answer is relational. Common entity characteristic, that term is related to relational database model. A cell is assigned the dash value if there is either no information or insufficient information about the characteristic of the location it represents. So how basically if no information is there, how is it represented? That is what the question is. Yeah, it is represented by no data. A way to flatten a globe surface into a plane in order to make a map is known as map projection. We just discussed it. Maps are models of virtuality, reality, rituality, potentiality. Yes, the answer is reality. Like whatever things that you are seeing, those things are represented on the map. Map projections involve distortions in a shape, size, distance, all of the above. Yeah. The answer is all of the above, which we were also saying. So, depending on your requirement, like if you are ready to like if you want the direction aspect preserved, then you have to go for cylindrical projection. Area means conical, so like that. Okay. Following is a type of map projection. Yeah. All of them cylindrical, conical, and azimuthal. Which projection preserves right angles between lines of latitude and longitude and are primarily used because they preserve direction? Yes. I don't think we have discussed this, but still, This is a information kind of thing. So the UTM map projection system consists of dashed zones, each degrees of longitude and width. Yeah, the answer is 60. So are you familiar with this UTM? Or it is basically universal it's known as universal. Okay, so I didn't discuss the DEM question because we had not discussed the DEM part today. That's why. That's why I skipped that question. I had included it in the next presentation. Okay, so yeah, as I was saying, this UTM thing, so universal transverse, it's known as universal transverse Mercator. I'll just discuss this, then we can maybe discuss the question also. So this is known as universal transverse Mercator. Okay, this is what UTM map projection means. So here it is a type of conformal map projection. What is conformal map projection? Or cylindrical projection. Okay, so this projection is a transverse cylindrical projection where the axis of the cylinder crosses the pole axis of the Earth's ellipsoid perpendicularly at the center of the ellipsoid. So it's basically like you have the Earth over here, okay? So you have these latitudes like this, okay? And then we have, yeah, you are right. It is the cylinder type, okay? So it's a bit difficult to draw with this pen. So yeah, you just imagine this is a proper sphere. So what happens is we keep it inside a cylinder, like you said. So uh, okay, it should not cut here. I'm sorry, my drawing is not that good. But anyway, it's that idea that you remember, right? Like it's kept tangentially, but instead of how the previous image, if you remember, we had kept it like this, right? Tangentially along the equator. But in this case, it's a more transverse kind of thing. So this is how we have kept it. It crosses the pole axis of the Earth's ellipsoid perpendicularly at the center of the ellipsoid. So what it does is it divides the Earth's surface into 60 time zones. Like we know this time difference, right? Like from the GMT Greenwich Mean Time, our Indian time is like 5.5 hours ahead. So like that. So in this case, it divides the Earth into 60 time zones of 6 degrees by separating the northern and southern hemispheres. So in total, we will have almost like 120 zones, like 60 for the north and 60 for the south. Hemisphere wise, it is 60 each, but generally we have 60 zones in total. each of 6 degree difference of longitude. If sir has discussed this in much detail in the next one, I can maybe discuss that. If not, it's an interesting topic actually, this UTM. So you can read up on it also. If not, I can also include it in one of our, like, probably we will have one additional session in which we can summarize the entire uh, course, or we can also include new topics, something which is interesting, some trivial topics we can include. Okay, so that, like, you mean you want me to discuss the UTM in the next class? Okay, okay. I will make a note of it. The UTM also I will discuss, and that semantic thing that you asked me, that also I will check and tell you, because I'm not that familiar. I just know the basic information, so I'll just make a note of it. Just a minute. Okay. And this question that I had skipped, that, oh, okay. The thing is, my class schedule is ideally from 6 to 8, and there is another teaching assistant who is taking from 7 to 9. The reason why few Tuesdays I couldn't take was like some technical issue was also there, and last Tuesday I was a bit unwell. So that's the reason. But the problem is, already if I'm taking on Tuesday, I cannot take from 7 to 9 because the other TA will be taking. But if I'm unable to take on Tuesday, and if I'm taking on some other days, maybe I can change it to 7 to 9 for your convenience. Okay. And this question that I had skipped, the SRTM DEM, like, if you want, you can give me the answer. Like the question, oh, I had not included it in the PPT. Like, the question was, SRTM DEM has voids which were filled with what kind of data? No data, zero, metadata, some data. The answer is no data, okay? Since I saw it as DEM, that's why I didn't include it, because Sir has discussed that in detail in the last lecture, and then in week 8, I think. So that we can discuss in the next session. Okay, so thank you so much for attending and patiently listening. And yeah, so shall I conclude the session? Like, you can exit if that's all. Thank you so much.